Hi, this is lesson 9.1, translate figures and use vectors. Our big question here is how do you translate a figure using a vector? You may also be asking, what's a vector? So we've got this frame, so go ahead and fill this frame in with me. It's all the vocab for 9.1. We'll be using these words really throughout the chapter. So this is about the basic vocabulary you need to know for 9.1. So the first word is image. And an image is a new figure created after a movement or change. So an image is our new figure. The pre-image is the original figure before a movement or a change. So the image is like the copy of something, the second thing. We start with the pre-image, pre means before, and then we get a new shape, that's our image. An isometry is a transformation that preserves length and angle measure. So we'll talk about isometries. Again, they preserve length and angle measure. A vector is a quantity with both direction and magnitude or size. So a vector really looks just like an arrow. A vector is going to look like that, kind of like a ray. But it's got a direction and it's got a size to it. So we'll talk about how we label those. The initial point and terminal point. Okay. We actually will do these, I believe, on the next lesson. So we're not going to do these first two words quite yet. Okay. So 9.1, translate figures and use vectors. So check out this frame here. This is about how we translate figures using translation rules and vectors. So we're going to have a translation rule. You'll have to understand and use translation rules, and you'll also have to use vectors. So the first thing, we're going to first look at example 1 here. It's translate a figure in the coordinate plane. And you'll see, I'm going to move on here. It's just a little bit bigger for me to write. So example 1 says translate a figure in the coordinate plane. So you'll see right here, we've got our pre-image, and then this right here, actually this whole thing right here, this is what we call our translation rule. Okay, and notice we've got this x comma y, and then we got the arrow, and then in parentheses x plus 3 comma y minus 3. You have to have this piece right here. This is part of the translation rule. If you don't write that down, you will lose some points on the test or on the quiz. So the first thing we're going to do is draw A, B, C, D. So I'm just going to plot my points. Negative 2, 6. 1, 2, 3, 4, 5, 6 is right here. Here's my A. 2, 4. So 2, 1, 2, 3, 4. Here's my B. 2, 1. So 2, 1 is my C. And D is negative 2, 3. So there's my D, and I'm going to connect them. This is what we call our pre-image because it's before a movement or a change. Okay, so here's my pre-image. And notice I just have the capital letters. It says find the translation of each vertex by, we're going to first do this plus 3. That plus 3 means adding 3 to each x coordinate, and then over here we have minus 3, so we are subtracting 3 from each of its y coordinates. So I'm just going to go through and all the x's, I'm going to add 3. So negative 2 plus 3 is 1. 2 plus 3 is 5. 2 plus 3 is 5. Negative 2 plus 3 is 1. So there's my new x values. My new y values here, well, I'm going to subtract 3 from all my y terms. So 6 minus 3 is 3. 4 minus 3 is 1. 1 minus 3 is negative 2. And 3 minus 3 is 0. So now I'm going to graph my image. I'm just going to do it in a different color here. So 1, 3 is right here. And that's what we call A prime. That little apostrophe there is, we read it as a prime sign. B prime would be over 5, up 1. So here's B prime. 5, negative 2, there's my C prime. And then 1, 0 will be right here. That's my D prime. So my image, after the movement, I label all the vertices with the same letter, but then I put the prime sign. If I then went and translated this blue image and found a third image, I would label it A double prime, so I'd put like this. There'd be A double prime, B double prime, C double prime, and D double prime. But every movement, you add one of those prime signs to it. So there's our first example. Our second example, it says write a translation rule and verify the congruence. So remember, translation rules are x comma y, 2, because this is our original point. And then we've got another ordered pair, and we're going to have x and tell us what to do with the x. And we'll have y and tell you what to do with the y. So our translation rules look like that. That's our general pattern here. So it says write a translation rule, or I'm sorry, write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. Then verify the transformation is an isometry. So remember, an isometry is a movement that keeps all the distances the same and all the shapes the same. Okay? So let's look here. We've got to start with A prime, and we want to move, or I'm sorry, we've got to start with A, and we want to move to A prime. So we've got to make sure we're going in the right direction. So if I start with A, to go from A to, right here now, to go from A to A prime, we're going to move 3 units left. Because I'd start here, and I'd go this direction, and that's 3 spaces. And we're going to go 2 units up. So I would then start here, and then move up to right here. And that would be 2 units up. So a rule for the translation is, well, we're going to take all the x's, and 3 to the left would be minus 3. And then all the y's, and we're going to add 2, because plus 2 would be a movement of up 2. So here, this whole entire thing is our translation rule. And again, remember, you've got to have that whole thing, otherwise you're going to lose some of the points. Example 3, identify vector components. So now we're going to start looking at some vectors here. So name the vector and write its component form. So this is what a vector looks like. Again, it looks pretty much like an array, except for we have a definite starting point and a definite ending point. So see how the arrow is right here? It's telling us that this is our end point. This G is our starting point. Okay? So first of all, naming the vector, we always put the starting point first and the end point last. And then on top of it, we draw a line, and instead of making a full arrow at the end, we only make a half an arrow. So we've got this half arrow with a line. This symbol right there is the symbol for a vector. I want to point it out. Can't say I didn't say, hey, you didn't say you do a half arrow. I'm saying it right now. We do a half arrow to show that it's a vector. So this vector is vector GH. Its component form is, okay, so this first number is how far in the x direction. And the second number is how far in the y direction. Okay? So we started our starting point, and in the x direction I go 1, 2, 3, 4, 5 over. So my 5 is where I start for the x. And I go 1, 2 down, so that would be negative 2. And notice, I don't have parentheses, I've got these like arrows here. We also use those arrows to show a vector. So we use those around a vector, and we use this symbol above a vector. So let's look at this next one. This vector is, again, my starting point is over here at R, because I'm supposed to have an arrow right here at S. It may not show it very well, but that's where your arrow is. So we're going to put R first and S next. The vector is, we got to say vector RS, so my vector symbol needs to go above it. So that's vector RS. Its component form is, so first of all, I need my x direction. So if I start here, I go in the x direction 1, 2, 3, 4, 5, 6, 7, and that's a negative 7. And then I don't move up or down at all, so it's 0. And again, it got those like arrows around it. They're not curved, and they're not like our parentheses. They're arrows. All right, let's look at our fourth example here. It says use a vector to translate a figure. So the vertices of triangle ABC are A, 0, 4, B, 2, 3, and C, 1, 0. Translate triangle ABC using the vector negative 4, 1. So first we're going to graph triangle ABC. So A is 0, 4. Here's A. B is 2, 3, 2, 3. And C is 1, 0. So here's C. And again, I'm going to connect them. So this is, remember, my pre-image because it's before any movements. So first, graph them. Now we're going to use negative 4, 1 to move each vertex 4 units to the left and 1 unit up. Okay. Now I'm going to draw vectors in for all of these. I'm just going to do it in a light color here. So if I went 4 units to the left from A, 1, 2, 3, 4, and up 1, be right here. Okay, so there's my vector that I drew in there. I'm going to draw it from B here too. So there's 1, 2, 3, 4, and up 1 and end right here. So my starting point is right there at B and my ending point is right here. Okay. And then C, I'm going to go over 4. 1, 2, 3, 4, and up 1. And it's kind of hard to draw a straight line here, just so you know. That's why my line looks kind of funny. It should be, definitely should be a straight line. So I've got all my vectors drawn in here. So I'm going to get a new color here. So my end point, my B prime is right here. My A prime should be right here. And then right here is my C prime. So this is my image. It's after the movement. My blue one is my pre-image, so before a movement. Notice how I labeled them. Okay. So we labeled the image vertices. We drew triangle A prime, B prime, C prime, and we noticed that the vertices drawn from the pre-image to the image, or I'm sorry, the vectors drawn from the pre-image to the image vertices are all these yellow vectors we're talking about. They are all the same. So that's what I want you to notice. Okay? So you can draw those vectors in to make a movement, but you do not have to draw those vectors in to make your movements when we're making our translations this way. So let's look at again this frame. You should now have all filled in. Our so what statement, though, down here at the bottom, is that you need to be able to graph and describe translations in component form and using translation rules. So you need to be able to do both of these things. So again, remember translation rules, you have the X, comma, Y, and then your arrow, and then your rule. And with vectors, when you're writing the name of a vector, you use a little half arrow at the end of it. And then also, when we're putting a component form for a vector, instead of putting parentheses, we put these little arrows. So those are a couple things that I wanted to point out to you. Please make sure you star any problems that you didn't get. Put a little note on your frame that if they didn't make sense, and we'll make sure we have time for questions in class tomorrow. Have a great day.